All right, so here we are, chapter 22. I found another of these absolutely ludicrous illustrations for the respiratory system this time. So what we're going to do is start again. We'll try to do 3 parts here, roughly the same length as the last set of videos, going over the respiratory system. Now, the respiratory system, as you might guess, right, major function here, respiration. That's not going to shock anybody. But we need to be clear about what it is we mean by respiration, because there are many different types, I guess, of respiration. One of the ones we've talked about before is the idea of cellular respiration, where we make ATP in the mitochondria in the presence of oxygen. As an final electron receptor, we end up turning it into carbon dioxide. This is not what we're talking about. Okay, this particular kind of respiration is not what we're getting at. What we're getting at are these 2 kinds of respiration here, external and internal. And what these 2 are is just exchange of gases, okay? With external respiration, this is exchange of gases with the outside world, right? So this is between the air and the blood, so this occurs in the lungs. And then also internal respiration, this is going to be gas exchange inside, right? In this case, between the blood and the extracellular fluids, so of course, in the tissues of the body. Now, there are other things or process, that's embarrassing, but other things that go into respiratory system, other functions we associate with that, including ventilation, which is the means of bringing air in and bringing air out of the body, olfaction, which we've talked about before, smell, and of course, what I'm doing right now, speech. So if we think about then what we mean by respiration here with the respiratory system, it's really these 4 different things. 2 varieties of transport, 2 varieties of respiration. So we're going to start with pulmonary ventilation. This is breathing, right? This is breathing out, all that good stuff. And this is entirely the role here of the respiratory system. We also have external respiration occurring. This is a gas exchange between the air in the lungs and the blood. So this is partially respiratory system, but also partially circulatory system, right? And in fact, as it turns out, most of this process is actually done by the circulatory system. So that's going to include transport, internal transport, moving these gases around in the blood. And then, of course, also the blood is the half of the parts here associated with this internal respiration. As far as the respiratory system itself goes, major organs here, most of these you'll be vaguely familiar with: nose, nasal cavity, paranasal sinuses. We've talked about some of these already back in A&P 1. The pharynx and the larynx, these guys have, pharynx at least has come up. Larynx is probably you're familiar with, but is going to be some new stuff here. Trachea and the branches thereof, so the bronchi, branches of the bronchi, and then the lungs and the alveoli themselves. So if we kind of think about where all of these parts are, well, here we are, right? We're going to assume that everybody is not a mouth breather here, right? And stick with the nostril here as being our primary entrance to the airway, followed behind that in the nasal cavity, down into the pharynx, to the larynx, the trachea, here where it branches off into the bronchi, and then from there, several branches here within the right and left lungs. We're going to divide all of those parts up into 2 zones because they're going to be doing 2 very different things. The first parts of that, basically all that you're seeing here, is going to be what we call the conducting zone, right? And it's just there for gas transport. There is no gas exchange happening here at all, right? It's there to move gas, right, to move air. It also conditions it, right? So we make it warm, we make it moist, we try to clean as much of the shit out of it as we possibly can before it gets to your lungs. And this is going to be everything from the nose, or mouth, one supposes, from the nose all the way down through structures we're going to call the bronchioles, okay, relatively small passages within the lungs. And then everything distal to the bronchiole is going to be in what we call the respiratory zone, right? This is where gas exchange actually is going to happen. So these would be the respiratory bronchioles, so the distal part of those bronchioles. the alveolar ducts, the alveoli. And if you're not familiar with these terms, don't worry. We're going to get there in a little bit. Now, there are going to be some accessory structures here, muscles, okay? They're going to be there for ventilation, right? So the movement of air into and out of the lungs. So these are things like the diaphragm, your intercostal muscles. There are external and internal intercostal muscles. Pec minor, scalene, sternum cladomastoid, internal, external obliques. You know, these are the reasons that I had you guys learn these guys in class, right? Because they're having a role here in ventilation for us. So if we start at the nose, right, this is, of course, the primary airway, right? Like your mouth, this is the nose. And its job is really just to moisten and warm and filter the air out, right? This is also going to be where olfaction is going to occur, right? The olfactory epithelium is here inside the nasal cavity, right? And it's also, if you're doing it right, it's also a resonating chamber for speech, right? So if you're speaking in your natural timbre, right, you should feel a slight buzz in your nasal cavity as you do that. We're going to divide this up into two parts, a vestibule. And the vestibule is the part where you stick your finger. And I know that you don't do this, but you know, other people, of course, when they pick their nose, right, this is where you stick your finger. And then everything that you don't want to stick your finger into behind that, that's the nasal cavity. That's the stuff inside your skull, basically. So if we look at a hemisected skull here, here is the nasal cavity behind. So if you remember from A&P1, the skeletal system, right, these are the nasal conchae, right, the superior, the middle, and the inferior nasal concha. And these are there to keep air circulating around, right, to keep it swirling around in there, hanging out along there so you can smell, number one, but also so it warms up, so it moistens up, all of that good stuff. Here, just this little part, right, you can see the nose hairs in here. This is that vestibule. Everything else behind this is the, is of course the nasal cavity behind that. And then from there, we're going to pass beyond the nasal cavity into the first parts of the pharynx, which we'll talk about in a little bit. Associated with this nasal cavity are going to be a series of paranasal sinuses. Again, we talked about these in A&P1. So these are the frontal sinuses, the maxillary sinuses, the sphenoid, the ethmoid air spaces. And these are connected to the nasal cavity, and they're there for a couple of different reasons. They secrete mucus, they lighten the front of your skull up a little bit, kind of take some of the weight off the back of your head and the muscles attach the back of your head to your neck. They can also serve as resonating chambers, right? So that if you have a blocked sinus, that's why your nose, your voice sounds kind of funny. And we care about them primarily in terms of rhinitis. Now, rhine here, like rhinoceros, this is the nose. So itis is an inflammation, so this is inflammation of the nose. And the issue with rhinitis here that we worry about so much is that because the nasal mucosa is connected to everything, right? It's connected to your airway, it's connected to all these sinuses, it's connected to your tear ducts, it's connected to your digestive tract. Any infection here can very, very easily spread to all of those places, right? One of the things we've talked about, and I hate to keep bringing it up, but one of the things that we've seen with COVID-19 is that if we can isolate the infection into the upper airway, this part of the airway, it's usually not so bad. Right, it won't progress down into the lungs, and you won't get pneumonia, and you won't die, right, which is good. But limiting that to this upper airway is problematic for this reason. It's connected to everything. One of the reasons you'll get sinus headaches associated with sort of an upper respiratory infection is that as it spreads to these paranasal sinuses, we block those passageways off. Air gets trapped in there, pressure builds, and you get sinus headaches from that. Moving back from the nasal cavity backward to the back of your head, we enter the pharynx. The pharynx is a muscular tube that goes all the way from the base of your skull back to C6. So if we kind of get a sense here, here's the bottom of the skull, right? And here's the top of that pharynx, right? Smack dab right there. And we're going to divide that into three parts depending on what it's behind. Okay, and again, I see another typo here. Sorry, it's supposed to be an X. Okay. These are the nasopharynx, which is the region behind the nose. The oropharynx, which is the area behind the mouth, and the laryngopharynx, which is the area behind the larynx. So if we look at just the pharynx here, right, we can see it divided up into these three sections: the nasopharynx, the oropharynx, and the laryngopharynx. Now, if we add a bunch of new stuff on there, right, we have a couple of different passageways into the pharynx from different cavities. So, for example, here we have the posterior nasal aperture, right between the nasal cavity and the nasopharynx. You'll notice that there's basically nothing stopping things from getting from here to there. There is no way of closing that off whatsoever. This is open permanently. When we talk about the oropharynx, on the other hand, we actually have a way of closing off this relatively small opening. This is the isthmus of fauces. Now, in your book, it says isthmus of the fauces. It's just the isthmus of fauces. I don't know why this "the" is there, but it is. But this isthmus of fauces, we can close off using a variety of different oral seals, okay? Closing off the oral cavity from the pharynx. We can do this with the tongue, okay? We can do this with the uvula. There's a couple of different ways that we manage to make that happen. So we can isolate our mouth from the rest of this passageway. It's how we breathe with things in our mouth, basically. And then from there, we're going to go down below this isthmus of fauces into the laryngopharynx, which is this space here behind this guy right there, the larynx, which is our next point of discussion. So the larynx itself is going to be the top of the dedicated airway. All right. Everything below the larynx is going to be just airway. If we look at the rest of the pharynx, this is a potentially conjoined food and air, right? Both of those things will pass through here. The larynx is going to be our first exclusively airway passage. And the beauty of it is it's going to be a series of large pieces of cartilage that provide what's called a patent airway, or a permanently open airway, right? If we didn't have these cartilages here, the airway could close and then we couldn't breathe. So we need to have something relatively stiff or rigid in there, keeping it open so that we can continue to breathe regardless. It is very much going to be the point of defense against getting food into the wrong space, right? So we have a little cartilage here called the epiglottis that we'll talk about in a second. It's this guy right here, right? Epi here meaning above, so it's above the glottis. So this guy right there then is the glottis, and this is going to be the opening into the airway. And we use this primarily here for voice production. When we look at the cartilages, yes, the larynx itself here in anterior view, okay, we see first the hyoid. This is not a part of the larynx, but it's what we attach the larynx to. Right up front, we've got one big old honking piece of cartilage right here called the thyroid cartilage. Now, you might guess this is where the thyroid is, and you're not wrong. But this is a really, really big chunk of cartilage right at the very top, okay? And it's got this anterior projection here called the laryngeal prominence, or the Adam's apple if you prefer that particular term. Now, it's really, really big here in anterior view, but when we look at the side view, right, what we're going to find is that it's only big here, and it actually gets really small towards the back. It's not a big piece of cartilage all the way around. It's really kind of asymmetrical in that regard. The one right below it here, this is the cricoid cartilage. This one is relatively small in the front. Oop, there we go. Relatively small in the front, but relatively big posteriorly. Okay, so again, asymmetry here. Now there are other cartilages here. There's the arytenoid and the corniculate and the cuneiform cartilages all back here. I'm not too worried about those guys. If you can remember thyroid and cricoid, I'm going to be pretty happy with that. Now this space right here that the glottis or the epiglottis can slam down on and close on, this of course is the glottis. And this is going to be where we've got a series of different folds. Now there's going to be a vestibular fold and a vocal fold, and we'll talk about those guys in a little bit. The vocal ligaments, okay, are a part of those vocal folds, and the glottis then So here's our vocal folds right there, or the true vocal cords is another way to describe that. These are there, and this opening between them is the glottis. And so the way that we produce sounds is we partially close those two vocal cords and we push air past them, and they vibrate as they do so, okay? And that vibration is actually what sound is, okay? And now we can actually also completely close the glottis, right, and use it like a sphincter. And in doing so, we prevent air from passing through here. Now, where this becomes important for us is that we can close it off and try to push air out. And as we do that, as we try to push air out, we produce a large amount of pressure here in the abdominal cavity, right? We're pushing way down on that. We're trying our hardest to kind of push this diaphragm down. And in doing so, we generate massive pressure down here. Now, this is called Valsalva's maneuver after a Russian test pilot. He used this to prevent blacking out under high G-force maneuvers, right? It's all wonderful and good. Because again, remember, right, what did we talk about with increasing pressure in the abdominal cavity, right? It forces blood from down here up towards the heart. Under high G-force maneuvers, right, blood is really being pushed down, okay, pushed out of the thoracic cavity, and so this helps to push it back up. You do this whenever you are on the toilet. I guess there's no real nice way to put it. When you're sitting down trying to defecate, believe it or not, you do this all the time because, again, you produce a lot of pressure down here. And producing pressure down here not only pushes blood up, it also pushes poop out. So it is something that you will do regardless of whether or not you realize it or not. So next time you're doing that, try it out. Don't tell me about it, but give it a shot. The other folds here, the vestibular folds, these are the false vocal cords. Now, if we look back to where we're at here, so here's the true vocal cords right there. And then just above them, these are those vestibular folds, or the false vocal cords. Now, generally speaking, the average person, no part here in making any sounds. There are some exceptions, and we'll see a video of that just in a second if I can get it to work. But the idea here is that they're going to help close the glottis during swallowing. Now, that's all well and good, but the other idea, I can do this here without exposing too much of what I'm doing, is we can also make some pretty cool sounds with it. So here is one of my favorite bands of all time. So that's pretty cool, right? So you can make kind of a low guttural sound out of it. Or you can also make an entirely different sound from it. Eventually we'll get there. Sorry, I probably could have cued this up better. So you can get all kinds of really wild and wacky sounds from something very, very, where do my PowerPoint go? Otherwise not designed to make any kind of sound, which is cool. Under normal circumstances, when you're trying to make some sounds, okay, the idea is, again, you're just going to partially close those two vocal folds and push air past them. The pitch of the sound that you make, okay, is dependent on how tightly you close them. Okay, so the more tightly you close them, the more tension you put on them, the higher the pitch is going to be. The lower they are, the more floppy they are, the lower the pitch is going to be. Now, part of the reason that we heard those weird guttural sounds from the false vocal cords is that they don't ever get really very tight. They're always kind of loose and floppy, and so you get that kind of tone from that. How loud it is depends on how much you're pushing up and out, right? So if you push air more forcefully, you get louder. If you kind of back off a little bit, you get a little quieter. This sound then gets adulterated a little bit. The pharynx, the oral cavity, the nasal cavity, your sinus cavities all amplify, enhance the sound itself. Kind of like when you sing in the shower, right? You're in this weird enclosed little space, right? And everything vibrates off the walls of that shower, and you actually don't sound like a horrible singer at that point. This is the same thing that's happening with your nasal cavity, your oral cavity, your sinuses, all that stuff. The final piece of the puzzle, when we get to language, is where we differ from a lot of other animals. We have a lot more control of the muscles of the tongue, the soft palate, the sort of floppy bits in the back of your roof of your mouth, and your lips. And together, those things kind of shape our sound into words and letters and syllables and things. From there, we're going to go down into the trachea. Okay, this is the quote unquote the windpipe. This passes down into the mediastinum. The walls of the trachea are made of 3 different layers of tissue. We have a mucosa. Okay, the mucosa here, again, like every other mucous membrane, right? Pseudostratified epithelium, goblet cells producing mucus. A submucosa in the middle. This is connective tissue. Okay, and then the outer layer here is the adventitia, again, connective tissue, but also within this adventitia, we have these C or horseshoe-shaped rings of cartilage, and those are what's going to keep the trachea open, right, or patent. We're not going to want this airway to collapse. That's, generally speaking, not a recipe for success. The C-shaped part of this becomes important. I'm just going to show you the picture here. The C-shaped part of it becomes important because in the back, we have a little muscle called the trachealis, right? So here's the esophagus, here's the trachea, the windpipe. This trachealis muscle right there. And that ends up being really, really important for us because we can kind of pull these 2 ends of our horseshoe closer together when this contracts. And when we do that, right, what we do is we make the lumen smaller. So just like when we talked about blood vessels and vasoconstriction, right, and we make the lumen of the blood vessel smaller, we increase pressure, we increase velocity. We're going to do the same thing here. So when you cough, when you have a forceful expellation of air, right, we're going to pinch that off to try to get as much force and as much power behind the air to get whatever is in our throat the hell out. Okay, and then the last thing, relatively important thing, you can see it here, right? This little dude right there. If we go back to way back here, farther back than I'd like, right here where the trachea ends and it splits off into the bronchi, there's this little underpants shaped piece of cartilage. That's called the carina. Carina just means tooth, okay? But it is where the trachea ends and the remainder of the passageway continues off into the right and left main or primary bronchi. Now from there, the bronchi are going to, so we split from 1 into 2, right? And then each of those bronchi splits 23 different times. Okay, well, there's 23 different orders of branching. It's called the bronchial tree. Now, we're not going to learn all of that because, frankly, there's no sense in it. But there are some sort of larger branching parts of it that we are going to at least generally learn that are going to help us understand how air gets distributed to various parts of the lung. So first we go from the trachea into the right and left. At this point, the right and left bronchi enters the hilum, here's that term again, hilum, of one of the lung. Okay, now they're asymmetrical. The right is wider and shorter. The left is narrower, more vertical. Not terribly important. But from there, right, either as we are entering the lung or just barely within the lung, we're going to split off again. We're going to go from primary bronchi into lobar bronchi. And this, again, asymmetrical. We have 3 on the right and 2 on the left. And the reason for this is that each of these lobar bronchi supplies 1 lobe. And our right lung has 3 lobes, and our left has just 2. So that's the difference between that. From there, we're going to divide from lobar bronchi into segmental bronchi. And these are going to serve, not surprisingly, segments of the lung, and we'll talk about what a segment of the lung is in a little bit. And from segmental bronchi, we enter bronchioles. These are relatively small. They're less than 1 millimeter in diameter. And bronchioles eventually branch into terminal bronchioles, which are less than 0.5 millimeter in diameter. And this is going to be the end of the conducting zone. Okay, so everything past these terminal bronchioles is going to be in the respiratory zone. So if we look at kind of a generalized view here of our bronchial tree, right? Trachea, carina, left, right, primary bronchi. Here on the right side, right, we split into 1, 2, 3 lobar bronchi. Okay, within a lobar bronchus, we split into segmental bronchi. Okay, and each of these segmental bronchi branches off into bronchioles, terminal bronchioles, so on and so forth. As we transition from bronchi to bronchioles, we change a little bit, right? So if you remember the trachea, right, we start off with very, very cartilaginous, very, very rigid. As we move smaller and smaller and smaller, right, we start to lose a lot of that cartilage and we get more elastic. Okay, we go from being very, very rigid to being a little bit more bendy and flexible. Okay, we're also going to change from having a lining that has a lot of mucus in it, or a lot of mucus production, so lots of goblet cells, to a simpler, a slightly thinner epithelium with less mucus production. Again, the smaller the passageway, the less we are going to be likely to want mucus in there, more likely that mucus is going to clog things. And so by not producing mucus there, we keep that airway open. We also start adding a lot of smooth muscle. And the reason for this is we are going to be very selective about where we pass air into. We don't necessarily want to have air going everywhere all at once. And so we can constrict off some of these smaller branches to kind of be specific about where that air is going. Okay? All right, so at that, we're going to go ahead and we're going to take a break here. We're going to come back and we'll start off with the respiratory zone in the next video.